Hi, my name is Sarah Hayes, and I'm an assistant professor in the chemistry department, and I am going to be your instructor for Chemistry 413 Instrumental Analysis this semester. And I'd just like to take this opportunity to introduce myself as well as the course to you guys. So this class is actually going to be super fun. We're going to learn about a bunch of different kinds of instruments that we can use to answer to sort of address all kinds of different questions, and these I hope these techniques will be applicable to you in your future, or at least some of these techniques will be applicable to you in your future employment or research, whatever direction you go. So basically what we're going to do this semester is spend most of the semester analyzing something like a stapler or a thing of makeup or something like that. And we're going to look at the metal content, the colors, odors, flavors, and the identity of the plastics that are used to make standard consumer products. And so we're going to learn about a bunch of different techniques that we can use to address these questions, and then you're going to develop your own procedures, write your own SOP, standard operating procedures for the different procedures that you're going to be doing and the different instruments that you're going to be working with, as well as sort of generating this knowledge about your consumer or your individual or your consumer product. You guys are going to work in pairs, so you and your friend, you and your partner will hopefully be best buddies as opposed to mortal enemies by the end of the semester. So I also wanted to take this opportunity to introduce myself to you. I'm relatively recently arrived at UAF by way of, I did my master's in analytical chemistry at University of Arizona, where I was using spectroscopy to try to develop better separations mediums to separate drugs. And so and then I did my PhD also at University of Arizona in environmental chemistry, where I was looking at the toxicity, mobility, and transportability of lead and zinc, mostly lead and zinc, although a little bit of arsenic, in desert mine tailings. And so for that I was using a bunch of spectroscopy, wet chemistry, some electron microscopy, and a lot of X-ray spectroscopy that's synchrotron based, which takes place at a special particle accelerator that's specifically designed to do X-ray science, basically. So I have a lot of experience with a bunch of different kinds of spectroscopy, although I do have a reasonable amount of experience with a bunch of the separation schemes that we're going to be studying this semester as well. So my research interests currently are in the cycling of toxic metals in the environment, and that impact on environmental mobility and toxicity, as well as transportability, and then sort of the next step is to look at how that impacts human health, human and environmental health. So after I finished my PhD, I did a postdoc at the U.S. Geological Survey, where I worked on tellurium, or where I started working on tellurium, which is the work that I'm continuing on at the current moment. And that project has sort of exploded in the sense that, it seemed very cut and dried when I first started, and now it's just gone in all these different really fun, entertaining directions. So that's all, and I am looking forward to meeting you all in class.